Hello, welcome to next episode of 2D game tutorial in Unreal Engine 5, and today we'll be working on the fight animation and roll animation. The game after this episode will look like this. We will be able to hit the F key and trigger the fight animation, and on the right click we will do the roll animation. So let's get to it. At first we have to import the fight animation images, so let's go to the hero sprites and click the import button, open the character with sword and shield, find the attack folder and import all the images there. Now scroll down to find out all the images in the sprites folder and select all of them and hit the right button, and from the menu select sprite actions, apply paper to the texture settings. Now open the sprite actions again and use the create sprite. I always reopen the folder now so the sprites are in a better order. And we can create flipbooks from 4 images which belongs to single animation. So select them and right click and create a flipbook. And we can name the flipbook FB, hero, attack, and then the direction. So in our case, down. We have to repeat the same process for all the images. So in the end, we will have 4 animations, 1 for each direction. Next, we have to add the animations to the animation source. So let's open the hero folder and animation source hero. And there we will add a new animation sequence and we can name it attack. And in this attack sequence, check the multi-directional sequence and set the animation for all those 4 directions. So for up direction, we will choose the attack up direction and the right one for the right and so on. So in the end, there should be good animation for each direction. We want to trigger this attack action when we press the F key, and for that we need to create new input actions. So let's go to the top-down input and actions folder and here create new input action. We can name the action AI_attack. Let's open it to verify what's inside, and the important thing is value type. It should be set to digital because it's either like pressed or not pressed, so that's fine. We can go back. Now go one folder up to the input folder and open the input mapping default, and we will add our input action there. The input mapping maps the input action to some particular key. So let's add a new mapping by clicking that plus sign and choose our input action for the attack and click on the keyboard image and hit the F key to set it to F. We can now save this input mapping and go back to the folder view. In the folder view, find the hero folder and open the animation blueprint hero. In the animation graph, in the locomotion state machine, we will add new jump there and we will call it attack. And we will later use this jump to actually change the state of the state machine to the attack. Then draw a line from that attack jump and create new animation state. And we can name this state attack state. Then we need to connect this attack state to the idle, because once the attack is over, we should go back to the idle state. We can open the attack state and there add the play attack animation, so the animation is played when we are in this state. We also had to set the directionality of this animation, and we can copy that from the walk animation. So let's copy the set directionality and connect it to the play attack on one side and to the output animation on the other side. There is one difference. We need the attack animation to be played just once, so uncheck the loop animation. Now let's go back to the locomotion and open the transition between the attack state and idle state. Our goal here is to set the can enter transition boolean to true when the attack is over. And the attack is over once the animation finished. To detect that, we at first need a player, so let's find the playback get player action and add it there. In the get player return value, we will search for get playback progress and also add it there. This action returns the number between 0 and 1, and the 1 means that the animation is over. So we will add the greater action and we will check whether it's greater than the 0.95 and simply connect the result of this action to the can enter transition, and that way we can detect that the animation is over and the transition should go to the idle. Now we have to write a code which will set a state of this animation state machine to the attack. So our attack state is triggered and the animation is played. We will do it in the top-down blueprints folder in the top-down controller. So let's open it. And in the event graph, find some free space down there, and we will add new event there. So right click and search for the AI attack input action and add it there. When this input action is started, it means the player pressed the F key and we need to jump to the attack jump node in the state machine. So at first we need to get the player character, because the state machine is stored in the anim instance class stored in that player character. Then we need to cast the player character to the top-down character so we can access all the variables and call the cast from the started part of the input action. Next we will get the paper ZD animation. And from the paper ZD animation we will get the anim instance. The anim instance is actually our animation blueprint, so we can call its jump to node action. We need to connect it to the cast to top-down character, and the jump name will be set to attack, which is actually the name of the jump node in the state machine. If we run the game now and press the F key, we should see the character attacking. The issue is that we can spam the F key and it will attack repeatedly in a loop. To fix that, we need to call the jump node only after the attack animation is done. So let's make some space there so we have some place to add some more actions there. We can copy paste the paper ZD animation and anim instance actions and move them to the newly created space because we will need them, and connect them to the top-down character. Next we will get the player, the same as we did in the state machine. And from the player we will get the anim sequence. From the anim sequence we will get the display name, and we will check if the display name equals the attack string. So from the display name get the equal exactly operator. And as the second string in that operator, type attack. Now we can add the branch operator for this condition and call it from the top-down character and call the jump node from this false part of this branch. This ensures that the jump node is not called if the attack animation is still playing. We can test it out in the game, so let's hit the compile button and start the game, and we can spam the F key, and we see that it's not showing the attack animation in loop anymore. Now we can add the roll animation, so it will be similar to previous animation. Let's go to the character, hero and sprites. And in the sprites we have to import the loop animation. So click the import button, select the roll folder and select all the files and import them. We will again find these files and select all of them and apply the paper to the texture settings and also create sprites from them. Now we have to create flipbooks from those animation sequences, so let's find some roll animation and select all those 4 images and create flipbook from them. We will keep the same naming schema, so we will name it FB, hero, roll, down or up depending on the orientation. We have to do that for all directions, so let's fast forward, and in the end you should have 4 flipbooks, 1 per each direction. Now we have to add the flipbooks to the animation source, so let's go to the hero folder and open animation source hero and add a new animation sequence, and we will name it roll. And again set the multi-directional sequence, and for each direction we will set the proper animation flipbook. It's the very same thing as we did for the attack animation, so let's fast forward. Now we have to create input action for this roll movement, so let's go to the top down, open the inputs and actions, and here we will create new input action. We can name the input action IA roll, and we can also keep the default values there, so we don't have to even open it. Now we have to go to the input folder and open the input mapping. Use the plus sign to add new mapping, set the input action roll, and as a key we will use the right mouse button. Now hit the save button, and we will do next changes in the animation blueprint. So let's go back to the characters hero and open the animation blueprint hero. We will go to the animation graph, into the locomotion, and there we will add new jump node. So right click and add new jump node and name it roll. From this jump node we will draw a line and create new animation state, and we will name this animation state roll state. We will create a transition between this roll state and idle state because we will go to the idle once the animation for roll is over. Now open the roll state and we will add the play roll action, so the roll animation is played. And we will again copy and paste the directionality from the other state. We have to connect the play roll to the set directionality and set directionality to the output animation and click the compile button. We can go to the locomotion and edit the roll state transition. This transition will be exactly the same as a transition between attack state and idle. So let's open that attack state transition and copy all those conditions from there to the roll state to idle transition. Now we just have to connect the output of that greater operator to the can enter transition and we are done here. To continue, we have to open our top-down controller in the top-down blueprints folder and we will implement the roll logic here. Most of the code for the roll action will be the same as for the attack action. So to reduce some code duplicities, we will reorganize a code a little bit. We can, for example, see that we are using the cast to top-down character twice here. So instead of that, we could just do it once at the begin play event. So let's copy those two actions and find the begin play event, paste it at the end of this begin play event. And we can connect it to the add mapping context. And we will use that as BP top-down character and promote it to variable. And we can name this variable as hero. Then we can go back down to those functions from which we copied this action and replace the top-down character with hero. So let's drag and drop the hero, find where the lines from the top-down character goes and replace them with our hero variable. So that was the first one, and the second one goes to the close actors, so replace it also there. And we can now also replace the white lines going from created to branch and from completed to branch. And now all the lines coming from the top-down character are removed, so we can also remove those two actions and reorganize the code a little bit, and we saved some time here and space. We will do exactly the same thing for the input action attack. So let's get the hero variable and replace the papers at the animation target input with this variable. And we will also do the same thing for the another papers at the animation action. Connect the white lines to the branch so they skip the top-down character, and we can remove this action and reorganize the code. The code left here is actually common code to jump to some node in the state machine to play the animation, and we will use the exactly same code in the input action roll. So let's convert it to the function. So we have to select it and hit the right button and choose the collapse to function. We can name the function play animation. Now we have to open this function and check what's inside. So let's move the play animation begin to some better place, and we have to set the input for this function, and this function will have the animation state as an input, and the type of this input will be string. Now we have to promote this animation name to local variable, so let's draw a line from it and click the promote local variable, and we will name it name and call it from the play animation and connect it to the branch. And we will simply replace the attack string with this variable. So let's do it for the equal exactly, and also for the jump name. For this, the Unreal converts it from the string to name, so we have to align these nodes. And now we have a generic function which can be used to play any animation from the animation blueprint. We can now click the compile button and go to the event graph. And in the event graph, we have to set the animation name for display animation function to attack. Now let's try playing the game to see if the game still works correctly. So let's play it and hit the F button to see if the animation still works. And it seems we didn't break anything. So back in the event graph, we can finally add the input action roll and start working on this code. We will use the started part of the input action roll, and we will call our new play animation, and as an animation name we will use the roll. We can now try playing the game, and if we click on the right mouse button we should see that the character plays the roll animation. The roll action should work like this. When the character is moving to some direction and we click the right mouse button to do the roll, it should stop the movement to that direction and it should instead roll to the direction where we clicked the right mouse button. So at first we will add the stop movement action, so the character stops moving to the direction where it was moving. And then we have to compute the vector from the player character to the mouse pointer so we know what the new direction should be. So get the hero variable and use its get actor location action to get the location of the player character. Then we need to get the location of the mouse pointer, so use the get location under cursor action. And to compute the vector, also known as direction, between these two locations, we need to use the get unit direction action. And we will connect the from line to the get actor location and to line to the get location under the cursor. The unit vector is a vector of length 1, so the numbers in the vector are between 0 and 1. And we will use this vector as a force pushing the character towards the right direction. So it's too small to be a force, so we have to multiply it by another vector to make the numbers bigger. To do that, we will use the multiply action. We will only change the x and y numbers in the multiply action because we are actually doing 2D game and the z is not that important when it comes to direction. The particular numbers, you have to try them to see how they look like when you play the game later. I tried it before and I know that 300 and 300 is actually good. Then we will add another vector to it, so let's use the add action. And for this vector we only set the z value and we will use 200 there. Again, I got the 200 number from the experiments with this code earlier, but in case you are doing this for the first time, you just have to put some number there and see how the game looks like. You may ask, why are we setting the z value for the 2D game, so let me explain that quickly. We have our top-down camera watching the game from the top and we have the character under the camera. If we apply x and y forces, the character will move to the right direction. But the x and y forces only defines how far the character moves. If we use big numbers, it will move further away, but it will move there much faster, and that's not what we want. So we can use the z vector there and define some number, and this will make the final vector look similar to this. And it will make the character move much slower, but still reach the destination we want. The character basically jumps, but because we are using the orthographic projection, it's not visible on the camera. So now we can go back to our code. Then we will make some space there and draw a line from the hero variable, which is down there, and call its launch character. The launch character applies the launch velocity vector or like force to the character and moves it to that direction. We want to completely override the character's velocity with the numbers we have in the vector, so we have to check the xy override and z override. And we also want to connect our vector to the launch velocity. Now we can clean up the code a little bit and connect the stop movement to the launch character, so it's executed. That's all for this function, and we can try running the game and hit the right mouse button and we can see that the character rolls nicely. So this is all for this episode, and the next one will be a little bit different because we will be focusing on the game design document. I will explain how the game will look like and what will be the game mechanics there, so I hope you will like it. Thanks for watching and see you next time. Bye.